Hello and welcome to my short video answering some questions that I received since I went live yesterday on Facebook regarding the supermoon. We're in November now and it's November 14th tonight, and I was out yesterday on the 13th looking at the so-called supermoon and trying to show some of my equipment and what I do when I go out and do either stargazing or look at the moon. But I got quite a few questions through on Facebook and I thought I'd try to answer some of them. Unfortunately, as you can see, I'm sitting at my computer because although it's the supermoon tonight as well, it's raining outside and total cloud cover, so I can't actually see anything up there apart from a hazy glow. So the first question is about why is this a supermoon? Well, it's a full moon, and what basically a supermoon means is it's a full moon coinciding with when the moon is in what's called perigee. Basically, the moon's orbit is elliptical, egg-shaped, and that puts it in its orbit around the Earth at either a close proximity to the Earth or far away. And when it's as close as it can be in its orbit, it's called perigee, and when it's as far away as it can be in its orbit, it's called apogee. And a supermoon happens quite regularly, actually. This is going to be the second of this year already. We had one last month, and a supermoon occurs when basically the moon is full, when the moon is also in perigee, so it's closest to the Earth, coinciding with it being a full moon. Now, of course, I've just said that these aren't particularly rare. We had one last month, we have one obviously today and yesterday, and we have one in December. So kind of what makes this so special, this particular moon, is actually to do with our relationship to the sun, because of course the whole year, throughout the year, the Earth and Moon system, the two items are also rotating around or orbiting around the sun. And that orbit of the moon and the Earth around the sun is also elliptical. So it has a perigee and apogee as well. And in fact, we're going to be closest to the sun in the first week of January. And it's that coinciding with the moon being in perigee to us and being a full moon tonight and last night that makes this a supermoon, because the sun's gravitational pull on our orbit around it causes it to stretch out and makes the moon basically as close tonight to us as it can be. So some fun facts, I guess. The moon is generally considered to be 250,000 miles away. That was certainly when it was the famous Apollo 11 landings in 1969. Well, tonight it's 221,524 miles away, so considerably closer in space terms, and that's making it appear 15% bigger in our sky. 7% actually larger than an average full moon, but 15% bigger than when it's in apogee or furthest away from the Earth. And quite significantly as well, it's actually appearing tonight 30% brighter. So it's not only 15% bigger, but also 30% brighter. And that's basically, as I say, caused by the fact that the Earth and the moon are as close as they can be in their orbit, and we are as close as we can be, almost, only 4 weeks away, to the sun as well in our orbit around that. And that coinciding with a full moon is what is basically called a supermoon. Of course, the size of the moon isn't actually changing, it's just our perspective of it. The moon is roughly just over 2,000 miles in diameter. I think it's 2,159, but I have to check that. To put some perspective on that, the Earth is nearly 8,000 miles across, so it's considerably smaller than the Earth. And both of those things are obviously fixed, but it's the closeness to the Earth that's causing it to be about 15% bigger and appear 30% brighter. Now, even if we could see the moon tonight, if you went out, you probably wouldn't notice a difference. You'd probably notice it being a bit brighter, but not much different, because you've got nothing to measure it by. Unfortunately, we can't have a moon in apogee and a moon in perigee in the sky at the same time to be able to compare them. But if you're able to take two photos, you would actually see that the moon is significantly bigger. Now this is a shot that I took last night when it was clear, and it was, as I said earlier, this supermoon, and another one, and you can see a bit of a clearer one there. Unfortunately there was a bit of cloud cover, so I had to mess around with the image to make it appear a bit clearer. Now, I guess the next question that came to me was, well, what about this date? Was it last night or was it tonight, the full moon? Well, rather unusually, it's both. Mainly because the moon actually reached its full size at 2 p.m. today, on the 14th. So, because it was daytime, we obviously couldn't see it. So that causes it to be a full moon on both the nights before and the night afterwards. I thought I'd show you some more photos that I took. This one here, I actually took back in October, and you can see the moon quite a lot clearer. This is just actually slightly off full, that's about 90%, and you can make out the seas of the moon, the black bits, which are basically caused by lava flow, and you can see the craters, the impact craters, the famous Tycho. You see it quite clearly there, and over here, one of the brightest features, Aristarchus, which is a very famous crater as well. But yeah, what's quite interesting is when the Apollo landings occurred, they landed just about here. This is the Sea of Tranquility, and you can just see that spot, that crater there. It was just slightly north of there where my arrow pointer is there, just there. And that actually, they did a lot more than just sample and walk on the moon. They actually help us measure the distance of the moon. Now, I said that figure earlier about it being 221,524 miles tonight, as opposed to 250,000 miles. And how do we know that? Well, when they landed on there, one of the last things that Neil Armstrong and Buzz Aldrin actually did was they left some mirrors. Of all things, they left mirrors on the moon. They're about 2 foot across, square-shaped. So they've been there since 1969, of course, without any atmosphere. They haven't decayed, so they're sitting just about somewhere around there. And in Arizona, there is a place called the Lunar Ranging Observatory, and what happens is every single night in the Lunar Ranging Observatory in Arizona, America, they fire a laser at the moon, and the laser hits the mirror. They have to sight it up using a large telescope. They hit the moon, hit one of the mirrors, and of course the laser light bounces back across those average 250,000 miles back to Earth, and because they obviously can do some maths with that, they can work out the exact distance. And so it's quite an amazing fact to think that from Earth we're firing a laser at a series of mirrors that are less than 2 foot wide on the moon, 250,000 miles away, or slightly shorter tonight of course, and they measure the time it takes to come back. And of course they can then work out with some simple maths the distance of the moon. And what they have found is something quite actually interesting. They've found that the moon is moving away from the Earth at a rate of 3.8 centimetres per year. Now that's actually quite fascinating. If I bring up another image, so you can just see this one a bit clearer, that's the same image but I processed it. So that's October's supermoon, and you can again just see that's where the Apollo 11 landings were in 1969. That's where the mirrors will be, and somewhere there there'll be a flag as well. And the fact that the moon is moving away from us at a rate of 3.8 centimetres per year is not going to have too much of an effect on us. It will never fall out of orbit because of some maths that I don't quite understand. But it will have a problem for viewing things like a total eclipse, because by pure chance, the distance from us to the moon, the size of the moon, and the distance of us to the sun currently, so in our lifetimes today, make the moon appear the same size as the sun in our sky. And that's how we end up with a total eclipse. So it's by pure chance, the size of the moon, and of course we said that the moon is, tonight it's 221,524 miles in diameter. That is, 221,524 miles away tonight, but it's roughly 2,000 miles in diameter. And its closeness to us and the size of the sun make them appear the same size in the sky, which is rather strange. but pure fluke. And that means that when the moon passes between us and the sun, it eclipses it. Now, of course, if the moon is moving away from us, so a rate of 3.8 centimetres a year, that means in the future the moon will appear smaller and will no longer be able to eclipse the sun, which will cause us not to be able to have total eclipses anymore, and you won't get that wonderful corona that you get round the moon where you see the sun's solar flares coming out, which of course cause things like solar weather and can be disastrous for electronics on Earth and things. So that's quite fascinating. Now, of course, the moon, another question that was asked is about whether this moon is going to affect things on Earth. Well, yes, it does. Basically, it's all to do with gravity, and gravitational attraction works in a way that the two masses, the effect that they have on each other, decreases inversely with the square of the distance between those two masses. So if you've got the moon and the Earth, the effect they have on each other decreases by the square of the distance between them. But what's quite interesting is with tidal forces, because of course water being a movable body, that varies with the cube of the distance. So that's actually having a huge effect. The fact we've got a supermoon tonight and last night is having a huge effect on both low and high tides. In fact, we're having some of the lowest and highest tides we could possibly have tonight and last night. So it does actually have quite an amazing impact on life on Earth and our ecosystem, And further to that, there has been some rumours and some research recently done, in fact, into whether these supermoons can cause earthquakes. Now, of course, this is sadly topical at the moment because there was a big earthquake yesterday in New Zealand. There was actually a paper published last year by Paris University, which was summarised in the Sky at Night magazine, which makes for some fascinating reading, because although scientists would say the jury is very much out on this idea that supermoons and the gravitational effect it has on Earth can cause earthquakes, they would say the jury's out. Some maths has been done on it and has shown that, in fact, statistically, significantly, there are more earthquakes happening on Earth than, that's annoying, isn't it? More earthquakes happening on Earth when there is a full moon, and that's greater than just being due to chance. So what scientists actually think, according to that paper that was published in Paris last year, is that these earthquakes would happen anyway, but they're kind of tipped over the edge into actually happening by the gravitational pull of the moon on us. So that's quite fascinating and quite scary as well at the same time. I'll just go to this shot here. We can take a look. This was again last month's supermoon, and you can just see, in fact it's just off full, I must have taken it the day before. You can see that when you have the Earth's shadow across, this is called the terminator. When you have, I'll be back and all that, you'll see that when the Earth's shadow, just where the shadow is actually the best place to look for craters. Because if you look at a full moon, even a nice clear one, like this one, actually that's again quite easy to see, but you often don't get to see, it's all white out, and that's because it's just too bright. So actually the best time if you're looking for craters is when it's not a full moon. You can clearly see it on this one. So this was a shot of the moon, and there's I don't think that is Tycho actually, I think this is slightly off centre. That could be Copernicus, yeah, I think that's Copernicus, the crater. But, so that's that looks to me like a 3/4 moon. Yeah, I've labelled it. That was taken back in September. But you can see the terminator across here, where the light meets dark, is the best place to look. Unbelievably, all this area here is likely to look like that as well in reality. But it's the fact, it's the contrast of the light and the dark. What we actually call the albedo, the contrast between the light and the dark, that makes you be able to see the craters. So that's actually quite fascinating. If you're looking for craters, don't look on a full moon, basically. And yeah, that business about tides. I guess the next question is, well, if it affects tides, does it affect humans? Well, again, very much the jury's out. Lots of studies have been done into looking at things like birth rates, death rates, and mental health during full moons, and there seems to be no statistical correlation between the two. In fact, I believe I read a study once where it suggested that births actually dropped around the time of a full moon. So make of that what you will. Trying to think of some other questions. I did write them down somewhere. Let me just have a quick look. Oh yeah, asking about craters. Going back to this image, which I think is the best one. One of my favourite craters is this one here called Tycho. It's a really interesting crater, and it can be seen with the naked eye, or with a good pair of binoculars. You'll see it really close. It's roughly 108 million years old, which in space-time is actually really short. And we know that because Apollo 16 landed just near it, and it collected rock samples and brought them back. So we know that that's roughly 108 million years old. The diameter across from there to there, if I see if I can find a shot to zoom in on it. Here we go, let's see, that's a pretty cool one. Let me just zoom in so we can have a good look at it. Again, when you get this close, unfortunately, it gets a bit pixelated, but that diameter across is about 25 miles, just to give you an idea from there to there. Bear in mind the diameter of the moon is 2,000 miles, 2,159, so it just gives you a bit of perspective. And the depth of it, you can just see a point in the middle. There's a like a bump in the middle, which would be a hill, kind of a mountain in range in the middle there. And the depth to the deepest part in Tycho is I'm trying to think now. It's completely gone. No, I can't remember. But I seem to remember that central peak is raised 1.6 kilometres from the ground. That's it, 1.6, that's Tycho, yeah. So that bump there that you can see that's shining, and of course it's an irregular shape, which is why it's catching the light so we can see it. That's 1.6 kilometres above the floor of the basin of Tycho, and remember that that's 86 kilometres across. What I love about Tycho, or the spot on the bottom, is these debris lines that you can see moving out from it, and in various shots you can see that to varying degrees. They are actually really massive. They're 1,500 kilometres long. They can stretch right across. You can see it goes up here, right the way off and round the backside, all the way round. So some of those are 1,500 kilometres long, 1,500. That's really, really massive. And this is a nice spot to see on the moon, really easy to see at the lower range. You can see it in almost all of the shots that I've got, even in the far away one. You can just about make it out there. You can actually see the shots coming around there, the debris trail. And you'll always be able to see that, providing that it's obviously not in shadow, which kind of brings on to another topic about why do we see this side of the moon. And it's to do with that gravitational pull, because remember that the moon is exerting a gravitational force on our seas. If you remember, it varies with the cube of the distance between the two bodies. But in fact, we're actually exerting the gravitational pull on the moon. And once upon a time, the moon actually span round much, much faster than it does now. But over time in its orbit, so its day, in other words, not the spinning round the Earth, but its actual, to do a revolution, its day, the moon's day, was actually a lot faster than it is today. And over time, the forces of gravity that the Earth had on the moon slowed it down to such a speed that, again, by pure chance, it spins at the correct speed to always show us the same face of the moon. So as it's traversing through space in its orbit around Earth, it's also rotating, but it's rotating at such a rate that we always see the same side of the moon. Hence the term the dark side of the moon. The dark side of the moon, the bit we can't see around here. And we weren't able to see that until the 1960s, when the Russians, just when they were the race to land on the moon, threw a probe around the other side and took some photos. And what's actually really fascinating, I haven't got a shot of it, but I've seen some of those photos, and of course more have been taken since. It's completely covered with craters. Now, it doesn't take much thought to realise that that's actually predictable, because this side of the moon, the light side of the moon, the bit that we see, is protected by Earth and its gravitational pull and all the rest of it, and the fact that we're in the way from meteors and things hitting it. Although, of course, there have been impacts that have got through, as you can see all over the pock-marked face. But if you look at the back side of the moon, look it up on Google, you'll notice it's completely covered. It doesn't have the seas, like the Sea of Tranquility that we spoke about here. It doesn't have any of this. It has lots of craters. and that's because it's completely bombarded by craters. And you can tell a lot from these craters, actually, even the ones that we can see. If I go back to another image here, the lighter ones tend to be younger. When I posted this actual shot a couple of months ago, last month, when was it? I can't remember. It must have been, I think this was the full moon of October, I said. Someone asked me about this spot here. Well, that spot there is very bright. Let me just see if I can zoom in a little bit. Zoom in a little bit on that. There we go. And that spot there is called Astakus, and it's named after the Greek astronomer, and its albedo, so in other words, its relative brightness to other objects, is twice as bright as any other object on, oops, I've just deleted that, let's just undo that, twice as bright as any other object on the moon. So you can see it, there it is, there, and there's another spot to look out for, Tycho and Astakus. I hope I'm pronouncing that right. You learn these names and you never know how to pronounce them. So that is actually, the reason why it's so bright is because it's only 450 million years old. Now that sounds old to us, but in space terms that's actually really, really a short time. Let's just zoom in on it again. Where is it? I'm going to just, there we go, so it's up the top here. It's about 25 miles across, and it's, to give you an idea on its depth, it's 2.3 miles deep. To give you a perspective on that, the Grand Canyon in America is 1 mile deep at its lowest, or its depth, I believe. So that's 2.3 miles deep. And I've been to the Grand Canyon, and it looks deep. So that's, as I say, 2.3 miles deep, and the sides are actually really, really steep. And that all helps to reflect its light. Plus, being so young, being 450 million years young, it hasn't, the debris from it, just like with Tycho, hasn't been eroded by solar winds. So the solar storms and the winds from the sun, which would darken it, which has happened to a lot of this around here, the seas and things, as well as, I believe, lava flow. So because it hasn't darkened, because it's so young, it hasn't been exposed long enough to the solar winds, what's actually happening is it's reflecting the light, it's whiter. And plus, in the middle of that, as I say, it's got very steep sides, plus a very uneven surface. And that means that it reflects even more light. So its albedo is twice as bright as any other part on the moon. And you can see it in, I think, yeah, there it is there. There should be Astakus. So, and this is another one of my favourite craters that you can just about see. Where is he? There, that's another big one to look out for. So you've got Tycho, over here you've got Astakus, Copernicus is here. And if you're looking for the Apollo landings, 11, the famous one, Neil Armstrong, and the mirrors, you're just looking for the Sea of Tranquility. I think that probably answers all of the questions that I was asked, apart from, oh yeah, the next supermoon hasn't happened for 70 years. The last time was 1948, so it was reported today. And to give you a bit of a perspective on distance for tonight, I did say that the distance tonight is 221,524 miles, but it just so happens that that is 100 moon diameters away. So tonight the moon is just around about 100 moon widths away from Earth, to give you perspective. Someone else, one final question someone asked me today was, what's a blue moon? If this is a supermoon, what's a blue moon? Well, moons are named according to what they were used to mark. Blue moon is an exception to that. So, for example, we've had a hunter's moon recently, we've had a beaver moon. This is actually, tonight's moon is referred to as a beaver moon within the Old Farmer's Almanac, which comes from the Native American tradition, where they would use the moon to announce different times of the year. And of course, it affects, although it doesn't statistically affect humans, the full moon does affect the behaviour of animals. So there is a deer or a stag moon, which is when rutting season begins, and things like that. But a blue moon is totally different to that. A blue moon is when you have 2 full moons in the same calendar month. So a blue moon is 2 full moons in a calendar month, and of course that's quite rare. If you think about the moon's orbit, so the moon's the moon's orbit around the Earth is 27.322 Earth days. So it takes 27.322 days for the moon to orbit and go through all its phases. So from one full moon to the next full moon is 27.322, and for that to occur in the same calendar month is actually comparatively rare, hence the term blue moon, which is why we say once in a blue moon, and of course the famous song. Well, hopefully for me now it's 22:36. I will check outside again, and hopefully it will be a clearer night later, but I doubt it. Looking at the weather tonight, it's been pretty shocking. So sorry I couldn't get out to produce the video I said I would do, but I hope that's answered some of your questions. And yeah, enjoy the moon. Everyone can see it wherever they are on Earth, and that's quite a comforting thought as well. But there's also those varying things to look out for, as I say, the craters that I pointed out, and the Sea of Tranquility where the landings were. Anyway, good night, and enjoy your next time you go out to do some stargazing.